The night leading into Pi Day, I stayed up and watched the total lunar eclipse, and I used some measurements I took to calculate pi. However, today is Tau Day, so let's reframe this in terms of doubling our results to calculate the other circle constant, tau. Now, I used a method which is outlined in my other video, and I took my measurements and put them into a spreadsheet, which then calculated pi, and in our case, tau for me. At first, it had a little error and said that tau was about 262, which is very wrong. I struggled a bit to figure out what it was and then fix this error, getting a lot more reasonable estimate using established values. I was now ready to take my measurements. The evening of Pi Day, I had come home from a hard day, and I took a little 2-hour power nap. Then I got up to my alarm, took some blankets and my camera out to the deck, and watched the eclipse, being sure to take pictures at least every 20 minutes. At first, there were 3 problems that caused my pictures to be blurry. First, I needed a special lens to trick the camera into not overexposing the shot, and I could not use this and the tripod simultaneously, which meant my pictures were a bit wobbly. Second, my lens was out of focus. Third, there was some stuff in the sky that was blocking my view. I asked Copilot what this was, and it turned out to be cirrus clouds. These cirrus clouds cleared out in time for the eclipse itself, but I'm going to talk more about them a little bit later. Now, as far as the actual pi calculation goes, I got the pictures that I needed, and I went to go ahead and calculate pi. At first, I got tau to be about 8.26, which is a bit high, and I'd say like a mediocre accuracy. Later, I found out that some of my equations were wrong, which caused the Earth's radius to be supposedly negative, which is wrong. I fixed that, but then the sun's radius was negative. And what I found out is that trying the established values, I got the correct radius, or at least approximately correct for the sun. And it turned out that that is just very sensitive to small errors in your measurements. But Earth's radius still seemed to be pretty stable around the correct value. This improved my estimate to about 7.84. Now, I will discuss the rest of the eclipse. It got to be totality, where the moon had gone all red, and it was really amazing. But possibly the most amazing part was what I'll show you next. I have very good night vision, and so this picture may be hard to see, but I went into Canva and enhanced the saturation and vibrance, and now you can see it. Again, I asked Copilot what was happening here, and as it turns out, the cirrus clouds were refracting the light from the moon during the first partial phase of the eclipse, and it made this really beautiful rainbow around the moon called a lunar halo. It was the birthday also of someone I know who liked rainbows, so I thought this was a special birthday treat for them and made sure to get the pictures. The next day was a very good day, and I was very happy with the entire night, and getting to see the eclipse. If you want to celebrate a circle constant this way, your next chances will be Pi Day 2044, Tau Day 2075, and Tau Day 2094. However, remember that it doesn't need to necessarily be on one of these days. Any lunar eclipse of at least partial umbral coverage will do.